Welcome back. In the last video, we created our first layer of the VIT architecture, the patch embedding. And we adhered to the quote from Lao Tensor, the creation of a deep neural network starts with the first layer. So it's very exciting, but we've got a few more layers to go. And just to show you that our assertion works, or we'll check if we can, to make sure that we've got the right image shape as we go through the patchify layer or the patch embedding layer, let's just create a random tensor, rand image tensor, and we'll set that to torch.randn, and we'll go 1, 3, 224, 224. So that's a good shape. So rand image tensor bad equals torch rand n 1, 3, 250, 250. So 250 isn't going to divide well by 16, which is what our patch size is. So let's just try to pass each one of these through. So patchify, we'll go rand image tensor. How does that work? Oh, rand, not random. Wonderful. We get the output there. But then if we try to put through the bad one, do we get an error? There we go. Oh wait, has no attribute patch size. What's going on here? Oh, self.patch size, we didn't initialize that. So self.patch size equals patch size. There we go. So input image size must be divisible by patch size, image shape 250, patch size 16. So that's just an example of our assertion, making sure that our input image is compatible with the patch size. So let's now jump back to the keynote. And we're up to equation 1, the class token. So we've done this little portion here, but let's remind ourselves of what the class token is all about. So in order to perform classification, we use the standard approach of adding an extra learnable, that's a key word there, learnable, classification token to the sequence. So we've got this at the start here. So extra learnable class embedding. And then we have this token right at the front of our patch embedding sequence. So similar to Bert's class token, we prepend. So prepend means to add to the front instead of append, which goes to the back. We prepend a learnable embedding, so our token needs to be learnable, to the sequence of embedded patches. So at Z0, 0, 0, so right at the start, equals X class, whose state at the output of the transformer encoder, Z0L, so that's this one here, serves as the image representation Y, so that this is related to equation 4 as well. So prepend a learnable class embedding token to the 0 index of the patch embedding. So how do you think we might do that? Well, if in doubt, code it out. Let's go here. I'm going to create a little heading. I believe we're up to 4.6 maybe. 4.6, we'll go creating the class token embedding. Now, what do we want to do? Want to prepend a learnable class token to the start of the patch embedding. Turn this into Markdown. So if we have a look, this is our patch embedded image. Patch embedded image. And don't worry too much if your numbers are different to mine. This is because we're probably using a different image or different random initialization, but the shape should be correct. So your shape should be something like this, or well, it should be exactly that. So the class token we want to prepend right at the start here of the number of patches dimension, that is. This will actually be 197 by the end of this section because we're going to prepend a learnable class token to the front of each one of those. So let's start with that. Now, how do you create a single learnable token? And I'll give you a hint, I'm pretty sure we covered this right back in PyTorch workflow fundamentals. Do we have parameter? Yes, here we go. NN parameter contains the smaller parameters like weights and biases. Put these together to make NN modules. So right back at the start, we created the linear regression model using NN parameter to create weights. And NN parameter requires grad equals true. So that makes it learnable. There we go. Requires grad equals true means PyTorch will track the gradients of this specific parameter for use with torch.autograd and gradient descent. For many Torch NN modules, requires grad equals true is set by default. That means it's a learnable parameter, which is exactly what we want, right? In order to perform classification, we use the standard approach of adding an extra learnable classification token. So let's see what this might look like in code. We'll start off by get the batch size and embedding dimension. And batch size, because we've got our patch embedded image, because we want this class token to work across batches. So patch embedded image, we'll get the shape, and then we'll get the embedding dimension. Now we already know these, but we want to be able to write code that works regardless of what the values are. So rather than hard coding the batch size or hard coding the embedded dimension, we want to get it from the patch embedded image. So then if we go, we got a typo here. Let's check out the batch size and embedding dimension. Wonderful. So right now we're working with a single image and our embedding dimension is 768. So now we want to create the class token embedding as a learnable parameter that shares the same size as the embedding dimension. So this will make sense in a second. D. So let's try this out. Class token equals nn.parameter. Why are we using that? Because nn.parameter is going to make this token learnable. And then for demonstration purposes, I'm going to create the class token as a series of ones. In practice, you'd probably use torch.randn, but ones is going to just make it more visible. So later on, when we make it officially, we'll use randn, but we'll start with ones. So let's go batch size. Then we only want one single token for the class token because it's just a single token, and then embedding dimension on the end here. So we've got a few steps there, but we'll see what it looks like in a second. And we'll go requires grad equals true. Now this is by default. We don't actually have to set that, but I'm just showing you that this parameter is going to be learnable. Now let's have a look at the class token. Beautiful. So we have a parameter containing all of these tokens here. And so if we go, let's get the shape, hey? So we have torch size 11768. That's beautiful. That's exactly what we want because we want to go patch embedded image dot shape. We want to add this one across every dimension of these. So that's why we have to match up the dimensions on the end here. So how can we do that? Well, let's prepend it. So add the class token embedding to the front of the patch embedding. Because if we go back to the keynote, we want it to be right at the front. So right now we've got this embedding. We want to add the class token to the front. So I'm not sure if we've covered this method yet of how to do that, but we will. So how could you add something to the front of a tensor in PyTorch? Well, let's look at that up. Add value to front of tensor in PyTorch. How do I add an element to a PyTorch tensor along somewhere? Oh, torch cat, that might help. Appending to a tensor, insert an element to a tensor. How to append an int tensor to a list tensor. So we've got a whole bunch of different options there, but let's just keep going. So I'm going to create a patch variable here, patch embedded image with class embedding equals torch.cat for concatenate, and then we pass in a tuple here or a list of tensors. So we're going to first want to concatenate the class token, which is what we just made up here, to the front, so that's why it comes first, class token to the patch embedded image. And what dimension do we want it to go on? Dimension 1, because that is dimension 1. Dimension 1, that is the number of patches dimension. Number of patches, we'll go underscore, number of patches dimension. And we got a typo here once again, no worries. So let's see what happens. So let's print out our updated patch embedded image with class embedding. Our variable names are getting quite long here. And then we'll go sequence of patch embeddings with class token prepended shape. So we'll go here. We'll get the shape of the above variable. So patch embedded image with class embedding dot shape. This is going to be batch size, if we've done it right, that is, number of patches, and then embedding dim. Number of patches, well, class token, plus number of patches. You ready? 3, 2, 1, let's go. Beautiful. That's exactly what we wanted. So we've now got a series of 1s at the start of our sequence of patch embeddings. So I did it with 1s to demonstrate, but of course, if we just change this to rand end, it's a little bit harder to see, but it'll do the same thing. Yeah, you can't really tell the difference there. So that's why I did 1s at the start there. So 1s, but in practice, we do rand end, so it starts with a random number and gets optimized. So now we've got this learnable class token right at the front of our sequence of patch embeddings. And you'll notice that the shape has changed to be 197 because we've now got a class token right at the front. So if we go back to the keynote, we've now got this section here. And you might see that ePOS, this is why ePOS, the shape of ePOS is n+1, because we originally started with 196 patches, but once we add in the class token, we now have 197, which is why we have number of patches plus 1. So over here, this is our linear projection of flattened patches, or in our case, we have 196 of them, but then we just added this learnable class token to the front. We prepended it, so now it's n, number of patches plus 1. So when we create our position embeddings, which is going to be in the next video, we need to make sure that it's the same shape as our linear projection of flattened patches plus the class token, which, the beautiful thing, we've already got that here. So we're almost finished with the patch and position embedding. We've got one more thing to do, and we've hinted at that already. It's the position embedding. You might want to skip forward and give it a shot yourself, but otherwise, I'll see you in the next video. Let's create some position embeddings.